Alrighty then. Refer to the following information when answering questions 20, 21, 22, 23, and 24. A student devised an experiment to find the concentration of sulfuric acid in a sample of battery acid. A measuring cylinder was used to transfer 10 centimeter cubed of battery acid to a volumetric flask. Distilled water was added to the volumetric flask until the volume reached 250 centimeter cubed. That 25 centimeters of sample of dilute acid was transferred from the volumetric flask to a conical flask using a pipette. A few drops of methyl orange indicator were added to the acid in a conical flask before titrating the acid with the sodium hydroxide. The titration was repeated 5 times, but concordant results were not obtained. Note, methyl orange is red in acid and yellow in alkali. Which suggestion would improve the chances of obtaining concordant results? So we got these 4 suggestions here. Why don't you pause up the video, have a go? All right, extra drops of indicator. I think that one's pretty easy to say. No, that's not going to make any difference. Use more concentrated. Actually, a more concentrated solution in the burette is going to mean that you get a smaller titra. So instead of 20 centimeters to neutralize, you might only need 7. And the problem there is any slight millimeter cube difference is going to be maximized. Like, you're going to have a bigger error. So smaller measurements, there's a bigger error in smaller measurements. Right. What next? Invert the volumetric flask several times after adding distilled water. Well, that sounds pretty good, right? They put in acid, which is going to be at the bottom of the flask. Then you top it up with another 225 centimeters or whatever it is, another 240 centimeters of water. If you just took 25 centimeters from that, the water's on top. I know it's starting to diffuse and spread out and mix, but the water's essentially on top. So you're going to get not the right amount of moles. It's not evenly spread. So you should put a stopper in and invert several times. You know, it's part of your core practical they're testing you on here. So essentially, in order to get the acid and the water to mix thoroughly, put a stopper in, invert several times. Then when you take your 25 or your whatever 25 centimeter sample from the diluted acid from the volumetric flask, it's a representative sample, right? It should be the same concentration as the rest of the flask. You're not just getting the water from the top that you've just added. So that is definitely going to help you get concordant results. Washing the pipette with distilled water between each titration is no good. No. You don't need to wash the pipette with distilled water. You're just diluting whatever you put in the pipette then, aren't you? You're just diluting the concentration of what's in the pipette. Which suggestion about rinsing the conical flask between the titration would improve accuracy? Should you rinse the conical flask with acid? Not sure about that. If you rinse it with acid, you're just adding more moles of acid to the flask. That's going to screw things up. If you rinse with alkali, you're going to get a reaction, neutralization. It's going to screw things up. You're going to rinse with water. Water is going to ensure that it depends if you're doing washings in between adding drops from the pipette, then that's going to ensure the reactants all mix together. And if it's after and you're going to use the conical flask again, you can rinse with water to get rid of any acid or alkali that's in the flask. Okay, which suggestion would reduce the overall measurement in uncertainty in the titration? So what's going to reduce uncertainty? Use less concentrated alkali in the burette. Use phenolphthalein indicator instead of methyl orange. No, changing the indicator doesn't reduce uncertainty. Using smaller samples. Actually, smaller samples, as I said before, are going to increase your level of error and uncertainty. Begin each titration with a burette. It doesn't matter whether you start at 5 centimeters or 0 centimeters. It doesn't change the volume you've actually added, does it? Use less concentrated alkali. If you use a weaker alkali, you're going to need more centimeter cubed of it. So if I use a strong alkali, say I need 10 centimeter cubed to neutralize the acid. If I use a weaker one, I might need 20 centimeter cubed to neutralize the acid. There's less error in the measurement of 20 centimeters using the same equipment. So if equipment has a fundamental 1% error, 1% of 20 is smaller than 1% of 10. So use a bigger volume. Which of these is important in ensuring the student's experiment is safe? Do the titration in the fume cupboard. You're not really getting any fumes here. If we look at the products of this neutralization, we're not really getting any gases, dangerous gases coming off. So you wouldn't really use a fume cupboard. You're more like with your organic solvents or your organic solvents. I've never heard of organic, but there we go. Wear gloves. Yeah, that sounds pretty good, doesn't it? Don't get battery acid on your hands, and don't carry a burette horizontally and poke someone in the eye. Okay, final question. Which color change? Yeah, so wear gloves was the answer to that one, folks. 24. Which color change is observed at the end point in each titration? So we've got to skip up to the stem of the question and check what they did. They added a few drops of methyl orange added to the acid. So we know methyl orange acid. What color is methyl orange in acid? That's our starting color. So you should know off by heart, put it on a revision card if you don't. Methyl orange is red with acid. Okay, and what color does it goes when neutralized? Now you might think it goes orange, the name methyl orange, right? But it actually goes yellow, and yellow's alkali. Yes, when you neutralize, you go slightly past neutralization point. It's like 0.00001, so it doesn't affect our results accuracy. So it's going to go red to yellow. And I guess it's called methyl orange because red and yellow make orange. There we go. Anyway, guys, don't forget, think about becoming a member. It's $1.99 a month. You get early access to my videos, and some videos are members only for the whole time. And I do chemistry A-level live streams, 7 p.m. UK time every Monday night. You might want to join, get some live questions in, and let's learn together. All right, sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks.
You're still here? It's over.